We now want to talk to you about the grading standards that you're going to use for completing exercise 2 in this class. This is a fairly simple lecture that will only have 3 parts. We're going to talk about some drafting and AutoCAD principles, grading plan specifics and guidelines, and annotation. That is how you do text for labels and for spot elevations on your plan. So to begin with, we want to talk about why we need standard graphics for grading plans. So grading plans are part of a construction set of construction documents that are used for a lot of different things. And these require an attention to detail, mostly because there are a lot of different people that are going to be using these drawings. First off, you're going to have multiple people in the office that are probably all going to be working on the same drawing. Then you have other professionals like architects and engineers and structural engineers that are going to be looking at it. And then finally, you have the contractors that are going to be building it and the clients that are going to be using it. All of these folks require the same visual vocabulary when we're communicating. So this is the place, unfortunately, that there is really no room for creativity. There are set rules that you have to follow when you're making these kinds of drawings. An example of a small set of construction documents. And the remainder of this lecture, we're going to be talking about what are some of the rules that you're going to have to follow in order to create these type of documents. One of the things you'll notice that these drawings all have a very consistent organization. They have the same sheet layout, they have the same title block, and those title blocks include things like scales, north arrows, text, and they all have the same graphic standards. Now we have actually provided you with title blocks that you can use for this course. You're not required to use them, but we advise that you do because they're actually very simple and straightforward. In fact, Natalie has provided videos for you online to show you how to use these title blocks, and you'll find these basic title block drawings available for you that you can XREF into your drawings for this project. So this is a cover sheet by Land Design for a set of construction documents, but this is not what's actually needed for the construction. Each with their own specific rules, to be truthful. In fact, this is only the top half of the drawings. And you'll notice that there are different line weights on these different drawings and different standards that are used. In this course, we're simply going to focus on the standards that are used for a grading plan. So to start your understanding of this graphic vocabulary, we want you to understand that there are certain abbreviations, symbols, and even line types that are used across the profession that are very consistent. You do not get to make up new line types or new symbols for things. You simply have to follow the standards that are already established. One of the things you have to do to follow those standards is you need to set up your AutoCAD drawing so that it has separate layers for each type of thing you wish to show. So for example, you will have a layer for existing contours. You will have another layer for proposed contours, and right down the line of the list that you can see here. Each of these will require a separate layer. And again, we have provided you with these layers that you may use for this course. You're not required to use these layers, but we very much encourage it because it's going to make it much simpler. As we proceed through the course, of course, we are going to be checking your DWG files to make sure that you have all of these different components on different layers. So our suggestion is that you simply start with what we are giving you as your different layers. This drawing with the different layer types also breaks down the line types that are different, and we'll even break down the different line weights that are required. We'll talk more about this later. But again, this is set up for you already, and Natalie has created a small video that will help you understand how this works. You really need to take a look at these and set your drawings up with this sort of system. And again, we need to reemphasize that this is not a place where you get to show us your beautiful graphic ability in illustrative drawings. These are going to be construction documents that need to communicate clearly to other professionals, so you need to learn and show us that you can master this graphic vocabulary. For example, these are wonderful renderings of trees, but this is simply not what you're going to be doing for this class. This is what trees look like on a construction document. It may not be pretty, but it's actually very effective and everyone understands what it means. So these standards are used in all drafting done for construction documents, and also for all AutoCAD done for construction documents. It's the same standards, but in this case, we're going to be applying it in AutoCAD. So for this exercise, you are going to recreate a drawing in AutoCAD. We're going to give you a JPEG as a base that you may insert into AutoCAD. And then if you think of it as tracing, it's similar to tracing, but there's a great deal of accuracy that we can do in AutoCAD that we could not do simply by tracing. So for example, all of the corners of the building would be absolutely square. All the lines of the building would be perpendicular or parallel to one another. This level of accuracy is what we're going to expect you to do in this project. All construction documents have to include graphic scales, written scales, and north arrows. We want to emphasize that it's very important that you actually have an accurate graphic scale on the drawing. The reason that you want a graphic scale as well as a correct written scale is someone may copy the drawing, photograph it, enlarge it, or reduce it, and you need that scale there to create a situation where the integrity of the drawing is not lost. One of the skills that you're going to develop as a designer is the ability to make lines that have different darknesses and different widths. We refer to this collectively as line weight. For this class, of course, you'll be creating those line weights in AutoCAD. There are standards, again, that you will need to learn to follow. Every office has different standards, but a drawing absolutely must have a clear hierarchy of different line weights. So we have again provided you with the line weights that you can use for this class. These are all set up for you with different colors and different plot aspects. There are instructions for this on the drawing, and there's also a short video from Natalie explaining to you how to use these. It is not required that you use this system, but we want to very much encourage that you at least try to use it because it's going to make this much easier as you go through the semester. The reason for these different line weights is that they are used to represent different design elements. So for example, buildings, walls, stairs, contours, etc. They are each represented by lines that have a different line type and a different line weight, and we'll explain this as we move through the lecture. This is important because a drawing that has all the same line weights is difficult to understand in comparison to a drawing that has a variety of line weights. You can see in this example, it's much easier to understand and read the drawing on the right than it is the drawing on the left. And again, here's an example of a drawing that has no line weight variation compared to a drawing that has good line weight variation. You also need to know that when you're working in AutoCAD, to see this line weight variation, you're going to need to create test plots, or PDFs in this case, so you can see what you're doing. It is a good idea, in fact it's paramount, that you make these test plots and PDFs early throughout the whole process. Do not wait till the drawing is finished to see what it looks like. Whenever you make a new layer, you should probably create a new test plot to see what the new line weight looks like. And here we've given you a general guide for line weights that you could expect to see on grading plans, from the thickest down to the thinnest. So this is a standard that you want to get used to. You should probably make a copy of this slide so you can keep it nearby when you're working on your drawings. And you're going to want to apply that to this exercise. So now you have a basic understanding of what we intend to mean when we say consistent organization. Sheet layout, title block, scale, north arrow text, line hierarchy, quality, and a clear legend. These are all things that you're going to need to include in this exercise. But we have a few more rules that we need to emphasize for you so that you can understand some of the requirements. Rule number 1, every fifth contour must be darker, thicker line weight than the other contours. This fifth contour is often referred to as an index contour, and it is done to make the drawing easier to read. So again, every fifth contour, whether it is an existing contour or a proposed contour, must be darker, thicker line weight. Rule number 2, whenever you are joining an existing contour to a proposed contour, you have to put in a tick mark. This tick mark shows the contractor where the limits of work are, and they will not move their equipment beyond these tick marks. Also, please note that these tick marks are to be perpendicular to the contours as they join. Now, this is easy to do when you are drafting, but when you're in AutoCAD, you will be tempted to simply take your tick marks and copy them from one contour to another. The fact is you can do that, but you're actually going to need to rotate them to make sure that they are in fact perpendicular at a consistent angle to the point where the existing and the proposed contours join. Rule number 3 is about the shape of contours, whether they are on hardscape or softscape. So when a contour is running across pavement, whether it's concrete or asphalt or whatever, it is going to be a straight line. When the contour is running across softscape or landscape areas, they are going to be smooth, curvilinear lines. This is always true. Rule number 4 is about the location of spot elevations. Spot elevations are always shown on the surface they are trying to control. So if you see in one of these circles, we have the edge of a sidewalk. The spot elevations are on the sidewalk itself. They are not on the smooth landscape area adjacent to it. They must be on the sidewalk itself. This is still going to be true for the corners of buildings, but that is going to show on the outside on the ground. So we want to make sure that our spot elevation is on the surface that we want to represent, except when we're talking about a building or a wall when it appears on the ground adjacent to the building or the wall. Rule number 4, spot elevations have to be located at specific locations in order for the plan to be constructed. And as I said a moment ago, if you're talking about a building or a wall, the spot elevation is located adjacent to that on the ground. One of the challenges you will find is getting all these spot elevations to show up in a logical manner. And we will talk more about how to align these so that they read well. In fact, we have quite a few more lectures that we're going to be talking about spot elevations. But for right now, you simply need to understand for this exercise, spot elevations for a structure are going to be on the ground adjacent to the structure. Rule number 5 is about text. Text, for example, should not touch other lines. If it is crossing another line, you need to break the other line or use text mask so that the text is clearly readable. The reason for this is that the text is the legally binding part of a drawing or a document, and therefore you have to make sure that they are clearly visible to everybody. You also want to keep your text consistent in size so that all of the spot elevations will have the same size text. All of the contour labels may have the same size text. You also want, when possible, to align the text in the same direction, especially if it's spot elevations. So you'll see in this drawing, all the spot elevation text are located at the same angle, whereas the texts that are used to label the contours, they are located at a different angle. And again, we're going to talk a lot more about this. So this might seem like a huge amount of information to take in on one little lecture, but we want you to understand that this is because these documents are used to actually build things, to make your designs real. And although sometimes these documents are used on paper, out on a construction site, they're often also used off of a computer. So this consistency is something that you need to develop in your skills.